Pangolins are just amazingly weird. Do any of you want to move down front at all? Do you have any, you're just holding back all the way around the back edges, okay? All right, great. How you doing? This is the last talk, and I'm going to be really pretty technical, so I want you to wake up, shake yourself in your seat. All right, you ready? Okay, we're going to talk about design patterns and modularity in the npm registry. This is who I am. The title means to me that I have all of npm engineering under my care. Not just the registry. I have the CLI and the website under my care. These are things that I worry about every day. The picture is not of me. It is the picture of my operations mascot, Malcolm. Malcolm will be referring to an emotional subtext through the presentation. So human brains are pattern detecting machines. We unconsciously search for and find patterns in everything that we do. You will have found a theme and a pattern to this conference, whether you're aware of the fact that you were looking for that or not, and whether the organizers of the conference intentionally put a theme there or not, you're going to find one. Because that's what our brains do. We see things, we match them to other things we've seen, and we find patterns. The process of writing software is a process of abstraction and then pattern extraction from the abstractions that we see. We as software engineers are obsessed with finding patterns. So we do it in software, we do it in code, and we do it in the systems that we build on top of the code. So what I'm going to do is talk to you about emergent patterns in the npm's registry. I'm going to descriptively talk about them. We didn't set out to put them there, but I've seen them now that we're there. And I'm not going to just talk about how they scale. I've talked about that a bunch. We're scaling. You're installing tons of stuff every minute from us, and you don't notice that. It's boring. Let's talk about modularity. This is one of the emergent themes of npm, and something practically every speaker has mentioned when they talk about code here. If they're not talking about community, they talk about code and they say the word modularity or modules. So let's talk about emergent patterns in the npm registry. What is the registry? I hear Isaac doesn't understand what the registry is anymore. So let's back up and define some terms. The registry, to me, is the system of services that manage packaged tar archives and package metadata. That's it. Simple as that. It doesn't talk about billing. It's not talking about websites. I'm talking about the things that let you put a package on the registry and then get it back again afterwards. So this is what I have to think of and serve as fast as possible to you every day. And we get some numbers. I ran these numbers on one of our Tarball servers just before coming up here, so this is pretty up to date. It's a lot of packages, but I would call this medium data. It doesn't fit in memory, but it does fit on a single disk still, barely. Disks are getting large enough, fast enough that may stay true for a while yet. And so it's npm's largest engineering challenge. Making the CLI work on all the hosts, all the machines you run it on is a significant challenge, but the registry is the largest one by the numbers. So I've learned a lot by doing this for you all over the last 2.5 years. I'm going to tell you some things that I've learned today. Here are some of the patterns that I've seen in the registry. Monoliths, microservices, transaction logs, and message queues. That's it's a mixed list there. So we're going to go through them and talk about how I've seen them come up and what I've learned about modularity in these patterns. Monoliths, we all know this one. Everything is in one big process. It's probably a rock. That's what lith means, right? One rock. Our website, most people's websites are monoliths. It's really easy to write a monolithic website. The registry was at one point a monolith as an app running inside couchdb. There's nothing wrong with monoliths. they are just fine. They're easy to write, easy to change. This is fantastic when you don't know what your problem is. You don't know what your users want. You don't know what you want. You want your code to be very squishy. So put it all in one place. The performance is more than good enough when you're measuring your usage in requests per minute, right? Anything is going to work. So choose the pattern that works to let you develop your app. Then Malcolm shows up one day and says, hey, guess what? You succeeded. Now what? You got to scale. It's not just scaling performance, right? You also have to scale the size of the team that works on the code. And these are two things where monoliths are less okay. The very same factors that make them easy to work on and squishable make them hard to work on later when you have to make them faster and you have to make more people work on them. Here, for example, is Malcolm yelling at 2 people at once. He has scaled by using 2 cell phones. What if he has to yell at a 3rd person? He's going to have somebody come and hold a 3rd cell phone. A 4th person, he's in trouble. This is how you scale a monolith. It's not actually going to work very well. The other problem is that it's really easy to write highly coupled code inside a non-modular monolith. And the reason is a human reason. There are no barriers to it. No cognitive conceptual barriers. You've got one repo, probably. You can change lots of things all at once, all over the place. Because you, as a human, understand everything that's going on. You held the whole system in your head. It's probably not very big. It's very easy to secretly couple your code together. Let's stop a moment again and be less vague about what modularity is. Where does this modularity come from? It comes from something, a really great term, information hiding. This term comes to us from a paper that I'm going to recommend to you all on the criteria to be used in decomposing systems into modules, D.L. Parnas, 1972. Could one of you look that up on the internet and tweet a link to it on the hashtag npmCamp right now? Somebody do that. The example that Parnas works through in this paper is very, very 1972. It's classic, the kind of programming problem that people had then, but the concept is key. And here's the concept. Information is data, how you structure that data, and the algorithms you choose to operate on that data, because data structures and algorithms are practically the same thing. If you hide information behind an interface, you can change it. Somebody looking at what a module does is looking at what the module exposes to the outside, the handles that it gives you to grasp and pull on the module and how it does things. If nothing outside your module can see how you structured things inside it, then you are free to change what's inside without breaking your users. This is why it's so important. When you hide things, you can change them. And for any long-lived system or any long-lived project, you're going to eventually want to change things because circumstances change. Malcolm is extremely interested in this insight because it is one of the great keys to programming. And if you ever understand it and can manage to do it the first time you do anything, please tell me, because I would like to know how to master this, because I can't. It is the constant struggle of programming, and the constant fun part of programming is figuring out how to do this right. Okay, so we have a monolith, and it's got code that isn't really all that modular inside. What do? The hot trend these days, you'll hear this at all the Node conferences, rewrite as a microservice. And that's exactly what we did, which is great because we are 100% on trend, and that's awesome. About half of the current registry is microservices, little teeny services that do a thing and talk to each other. Great thing about microservices is that when you write them, you are forced to design an API of some kind, and you are forced to put your implementation inside a service away from everything else somehow. So modularity is kind of thrust on you, kind of, sort of, at least an attempt at modularity. They can still mess it up. Unfortunately, as you probably already know, people, this is why. A human is writing the code. A human knows how things go over here, and a human writing code over here is very, very tempted a lot of the time, particularly under time pressure, to take advantage of what they know about that thing over there, over here as they're doing their job. Because the human doing the typing knows it all. The services they develop can know far too much about how data is structured or how the data needs to change when a package gets published or something. You can scatter a task across multiple services in a microservices architecture. You can make retries and failures hard to cope with. You can have somebody start doing something here, continue doing the same thing here, and then try to clean it up over here, and over here doesn't know enough. I might be mentioning this problem for a reason. I think, I'm going to look at an example here. Let's look at what happens when you publish a package. Here's a block diagram. I love making block diagrams. Doesn't this look beautifully modular? Look at all these little like, diagrams with service names in them. They have arrows connecting them. There's a secret horror hidden in this diagram. And it's in the horror of two arrows that point to the same thing. When you authorize to publish a package, the auth plugin goes and talks to the user access control list server and sets up a bunch of package access stuff. Because that was the easy way to do it at the time, and we knew we needed to do that. It sets it up as a side effect. So what happens if a service crashes midway through publication? Or if the validation server says, nope, sorry, this isn't a valid package, SHA-SUM's wrong, boot. Well, we have user access control tombstones sitting in the database that we have to clean up, that one service doesn't, the service further down the chain doesn't know about these access control lists. Malcolm is not relaxed. Malcolm is off to yell at some databases. I'll relax, though. We'll come back to this topic, but right now I'm going to relax. Because after package publication, it kind of gets awesome. After package publication, we do this amazing thing called the transaction log. You might hear this is called a transaction log, a write-ahead log, a commit log. This is a great pattern. I love this pattern. Learn this pattern. Here's another paper I want you to read. Actually, it's a blog post. Somebody looked this one up too. The log, what every software engineer should know about real-time data's unifying abstraction, written by a LinkedIn engineer. LinkedIn, of course, wrote this amazing thing. Well, LinkedIn is an amazing, spam as a really very highly scaled service. So we can learn a lot from LinkedIn. So couchdb is the database at the heart of NPM, and it has a superpower. You heard this superpower talked about earlier today. It is the changes feed. This is a commit log, pretty much, that you can use to get data about the current state of every document in the Couch database, which for us is every package in the registry, in the order of least recently modified to most recently modified. We write a whole bunch of things called registry followers, which are consumers of this commit log. It's exactly the same pattern that Greenkeeper uses, that we use internally to follow what happens when packages get published. And this is like really cool. This is a very highly accurate diagram of all the consumers we have that do various things. We fan out like, whoa, after a package gets published. Here's an incomplete list of the things we do when you publish a package after the fact. Before you publish, the clock is ticking. We want to get that publication in as fast as possible so that you get a response as fast as possible. But after publication, we can relax. We have tens of seconds to do things. We distribute tarballs, we invalidate our CDN's cache, we populate PostgreSDB so the website can see the updates. We put index data in Elasticsearch so that well, it's not a very good search, but we have it. There is a search. We scan packages for security leaks. Did you know this is a thing that we do? If you accidentally publish your npm token, we will invalidate that token for you. We populate our internal registry mirror that we rely on for our operations. And we fire webhooks. And we do a bunch of other things, too. Each one of these followers is a separate process. Each log consumer does one thing well. It's really easy to be modular when you're doing this. This is so awesome that the 12th doctor has showed up to say, yes, this is awesome. OK. All right, let's come back to publication. Fine, let's fix it. But how are we going to fix it? Now we enter the speculative portion of the talk, because this is like what we're thinking about doing and what we're sort of moving on now. I'm tired of microservices. Malcolm is tired of microservices. We messed up the modularization. Unwinding failure is a pain. Got to figure out how to do this. OK, 2 words. Message queues. Message queues are an inversion of control. Microservices are very imperative. You have code with a bunch of mutable data saying, OK, do this next thing. I'm handing it off to the next bit of code. It's going to do this next thing to it. And the data is going to mutate as it goes through. With the message queues, you do it kind of the other way around. You have an immutable message that says the state of a task and what the next thing that needs to happen is. You have a message in your message queue is a kind of a request for work. You can have workers consume messages, do a thing, retry, if that's appropriate, or unwind on failure. And because one place encapsulates the state of the work that was done or needs to be done, it's a little clearer to figure out what to do. Worker should, unfortunately people, do one thing, and then put the message on the queue for the next worker to do the one thing. And you kind of scale it the same way you scale out commit log consumers. Here we have 4 Malcolms running around. If we needed to yell at more people, we would just make more Malcolms. The queue has to be reliable. Workers can crash. It's OK. We have a message sitting in this robust queue. It's a database. We hope our databases are reliable. They aren't. Don't tell anyone. This is a really popular pattern. This is so popular. Go to queues.io and look at all the queues. I imagine that this isn't all of them. But reimagine, as I do, what publication looks like if we do it in a message queue. It's much more controlled. Publication is a series of steps in which data enters the registry. Each step can succeed or fail. Failure can trigger a rollback and then tell you, oops, sorry, you don't have the right to publish that package. Queue disadvantages? I don't know. We don't have them in production. Clearly, there are infinity disadvantages or 0 disadvantages. I don't know. But this is the next big trend. This is often where systems need to go to when they need to scale to the next level, when that first level of distributed systems doesn't work for you anymore. So, I don't know. Malcolm and I, neither of us know. You can mess up writing a queue worker just as badly as you can mess up writing anything else, because the hard part is in the brain of the human writing the code, always. So what's the pattern we get from this discussion of patterns? The registry is a pretty small distributed system. Really, all things considered. LinkedIn, that giant spam farm, is much, much larger. I don't even want to think what Twitter looks like inside. That's big. We're small. We can learn something from it anyway. And the lesson that I have is going to shock nobody. You ready? There is no silver bullet. There never is a silver bullet. Fred Brooks was right. None of these patterns are wrong. None of these patterns are right. It's all about the specifics of where you are with your project. It's trade-offs all the way down. It always is. You can't fool me. What problem are you solving? Do you understand the problem you're solving yet? If you don't understand the problems you're solving yet, you should probably pick something that lets you squish it around, squish the code around a lot while you're experimenting. Write a monolith. What tools do you have to hand? Microservices are very attractive, but they actually add a lot of complexity right from the start. You have to think about how you're handling retries and failures right from the start, otherwise you're going to get in a big mess. What is your team experienced with? Are they like, yes, we use message queues all the time. We speak RabbitMQ like Kafka, we got it. In that case, like, you might want to go with a message queue-based architecture from the start. Though, again, what problem are you solving? You will need to fight for modularity no matter what you pick. We messed it up. We know that modularity matters. We live small modules. We still sliced them wrong. That's fine. It's okay. You live, you learn. You write code, it's wrong. You write code, it's right. I swear it's accident. But the upside is that you can have modularity no matter what you pick, because it's all in your brain and how you think about the problem that you have. Make your users happy first, because that's the hard part. That's where projects actually fail. I guarantee you, probably very few projects have failed because they picked one of these patterns instead of one of the other patterns. They fail because they don't connect with somebody who wants to use them. Here's the other thing I've learned from working at NPM over the last 2.5 years. You can change them. This is a surprising thing. You think of like code as being this big, heavy weight that you can't move, but you actually can. You can, modularity, I gave a talk about this one, and this is like, I just want to say it again. Modularity is a salvation. If you've hidden something, you can change it. And that includes from yourself. You can put proxies in front of things so that you internally don't care whether it's this service or that service implementing something. We right now in production have like a user ACL service that's legacy and a user ACL service that's new, and they're both handling requests. We just switch between them depending on like what the request is and which service knows how to do this, and we're gradually shifting more and more load over to the new one. And when the old one is finally not handling any requests anymore, we'll take it out of production. And you won't have noticed anything. And most of the engineers in NPM won't have noticed anything either, because we hid our implementation from ourselves in a really kind of cool way. You can change everything that you did. You should probably plan on changing everything you did. It's going to be OK. You will get it wrong, and then you will fix it and get it right. So I'm going to try message queues for publication. We're already taking little baby steps in this direction. And check back with me next year to find out how we messed it up, what went right, what went wrong, how much I hate the message queue we picked. Because, as you know, the way to hate a database or anything is to put it in production. You love everything before you use it, right? So, you'll see me. You'll see me again, as I'll talk about like what I've learned from the next few set of steps that we do. And you'll see me again tonight if you want to come to the after party. Please, I encourage you all to come to the after party because I'm going to be DJing. Thank you very much.